Mr. Harridan here. Today I'm going to teach you how to use the compound naming flowchart that you get to use on the first quiz. Okay, this will be provided for you on the first quiz. It just won't have any examples of polyatomic ions on it. You'll be also given the usual periodic table as well. And then hopefully you have your polyatomic ions memorized. So starting off with K2CO3 here. Ionic covalent or acid. Well, K is a metal, so then we know that this is ionic. So I'm here on the flow chart. Okay. CO3 is a polyatomic ion, so I'm doing metal and polyatomic ion. Name the metal, potassium. So we write down potassium. Name the polyatomic ion, carbonate. So we write down carbonate. Okay. Then on our flowchart, if the metal has more than one possible oxidation charge shown using Roman numerals, applies to groups 3 through 15. So that is 1B to 5A for me here. Except groups 13, zinc, cadmium, and silver. Okay. Well, potassium's in group 1, so we do not need a Roman numeral. So this is ionic. Does metal need no Roman? Because it's group 1A. Group 1A does not need a Roman numeral. Okay, let's go down and look at the next one. ZNO. Okay, ZNO. Okay, first we have zinc. We know that is a metal. So again, we are in the ionic stage. This time, O is a nonmetal. So we have metal and nonmetal here. So name the metal, zinc. Name the nonmetal with an "ide" ending, ox. Okay. If the metal has more than one popular oxidation number, show using Roman numerals. Applies to groups 3 through 15, except group 13, which is the aluminum group. Zinc. Oh, zinc. No Roman. Zinc does not need a Roman, because zinc is always +2. Okay. Let's go down to the next one here. C7H16. Okay, so carbon is a nonmetal. So now we're over here on the covalent side. Okay, so this is covalent. Is the molecule organic? Does it have C and H? Organic. And I can't write the word organic because it doesn't fit there. Okay. Carbons indicate prefix. So we have 7 carbons. So we're going to use hept. Add ane ending. Ane. Determine if it needs a cycle in front of the name. If it is a double, oh, you're not even seeing where I'm looking here, Mr. Sheridan. Oh boy. Anyways, says add ane. Determine if it needs cyclo. Okay, so CN plus 2N plus 2. Or if it's a double, it needs a cyclic. Well, this is not a double, so this is just heptane. Easily done. Okay, here we go. The next one. Bi, parentheses, BrO2, parentheses 5. Bismuth. Bismuth is a metal. This is ionic. Okay. And we have a polyatomic ion, so we're right here on this side. Name the metal. Bismuth. Okay. Name the polyatomic ion, BrO2. Okay, BrO3 is bromate, so this must be bromite since I subtract an oxygen. Okay. If the metal has more than one possible oxidation number, show choosing using Roman numerals. Applies to groups 3 through 15 here. So this is group 15 here, so this is a Roman. Roman, Roman, Roman. You need a Roman numeral. You need a Roman numeral for bismuth. So this is where you have to figure it out here. Since bromite is -1, and there are 5 of them, 5 times -1 is 5. So bismuth must be +5. So this is bismuth 5 bromite. That's the official name. Oh, Mr. Harridan, you messed up the sheet here. HBr, this is supposed to have an AQ after it. What type of compound do we have? It's not ionic, it's not a metal. Covalent, nope, we're in the acid range here, so we have to look at our acid rules for this. So is it H plus an element or H plus a polyatomic ion? This is H plus an element. Okay. So, and I have to have the AQ to have it be an acid here. So, for H plus an element here, we go down to, it's not an 8 because that's polys. It's not ide, that's a polys. Non-metal, ide. So you change it to hydroic. So this would be an acid here. I want to write that in a different color. So this would be hydrobromic acid. Okay, so this is an acid. And it is an ide acid because it is bromide. Okay, then we get to the next one. MgSO4.7 waters. Mg is a metal, so we're in the ionic part. We're over here, metal and polyatomic ion. Name the metal. So this is ionic. Metal is magnesium. Okay. SO4 is sulfate. Okay. Magnesium is in group 2, so we do not need a Roman numeral, so there is no Roman on this one. Magnesium is always +2. Okay. But then we have to go down to the hydrate part here, where it says hydrates. Name the ionic salt. We already did that. Add the word hydrate for the waters. Use the covalent prefixes, which are the ones over here, right, to indicate the number of hydrates. So since this is 7 waters, this would be magnesium sulfate heptahydrate, which is also known as Epsom salt to the common man. Good for growing roses, just so you know. Okay. H3PO4. Oh, this starts with H. I must have an acid. So I'm in the acid here. PO4 is a polyatomic ion, so I got to use the poly rules, right? So this is an acid. This is an acid that ends in 8, because PO4 is phosphate. And then 8 goes to ick. I ate something icky. Last night I got nauseous. And then I ride a hydraulic plane. So 8 goes to ick. So this is phosphoric acid, which, if you're in my class, you see me drink every day because that's in my soda. It's on here. Phosphoric acid right there. Ooh. Can't live without my phosphoric acid. Okay. Keep going, Mr. Harridan. You got a long video to make here. N2O. Okay, so N is a non-metal. So we're in the covalent area here. So this is covalent. This is the inorganic ones. These are the ones with prefixes. Okay. So name the first non-metal except with prefix except for mono. So we're going to name the first one. So this is dinitrogen. Okay. Name the second prefix and add ending. So 1 is mono. So this is dinitrogen monoxide. Okay. USE3. U is one of those inner transition metals. It's way at the bottom. So that is uranium. So this is ionic. Don't you think? It's like when a metal loses its electrons to a non-metal. Okay. So we're going to go over here. Okay, so we have metal and non-metal, so it's actually over here. Right, so we name the metal uranium. We name the non-metal with an ide ending, so this is selenium, so it's selenide. Then we determine if it needs a Roman numeral. Since it's an inner transition metal, way at the bottom, we do need a Roman numeral here. So we need our Roman numerals tell us the charge. Okay. So again, we have to back figure out the charge here. Here, selenium is in group 6, so that is -2. 3 times -2 is -6. So uranium must be +6. So this is uranium 6 selenide. Everybody's favorite compound. Okay, NH4Cl4. Okay, well, NH4 is a polyatomic ion, so we are on the ionic side again. And we have 2 polyatomic ions here, so this is NH4 and polyatomic ion. Name the metal or ammonium, so we're going to name ammonium. Then we're going to name the other polyatomic ion, ClO4 perchlorate. And ammonium does not need a Roman numeral, so there is no Roman here. No Roman. Okay, because we have ammonium, which is always +1. Okay, and then CdMnO4 here. Cd is a metal. Okay, so again, we're doing, isn't it ionic? Don't you think? It's like rain on your wedding day. So we name the metal again, cadmium. Right? You name the polyatomic ion. Oh, that's one of the harder ones. That's one at the bottom there. That's the permanganate. Oh, I hope you have those polyatomic ions memorized. You do. I'm not worried about it, right? And then we check to see if it needs a Roman numeral here. Groups 3 through 15, except cadmium +2. So cadmium is always +2, so there is no Roman. Okay. Hopefully that gives you an idea on how to do the naming stuff there. Okay, let's move down from going to the other way here, which you would use the other side. Cyclononane. Okay. So this is an ionic because there's no metal listed or ammonium. It doesn't have the word acid, so we are in the covalence here. Okay, so we are in the covalent column here. Okay. These have prefixes. Determine the covalent is organic. One word in the name with an ane ending. Oh, that is organic. Okay. If it is a cyclo, remember it is a double. Okay. So these are your hydrocarbons. So you have your C and your H here. You know nana from the other side says it's 9. And then you double for the hydrogen, so it's C9H18. Tin 4 sulfide. Tin is a metal, so this is ionic. Okay, so this is tin 4, so this is Sn plus 4. Sulfite. Sulfite is SO3 2 minus. Plus 4 and 2 minus does not equal 0, so you need another 2 minus. Or as if I was to write this, I would write it this way. So I have 1 Sn and 2 SO3s. So this would be Sn parentheses SO3 2. Okay, here's where we start to get confused here. We got hydronitric acid. This is an acid. You'll be able to pick these out because they say acid. Just so you know. Okay, determine which ion is based off the name here. So we have hydronitric. So we're looking at the hydronitric acid. So this is the I, so this is the non-metal here. So when we're doing this here, we got the H plus, because all acids start with H plus. And since this is the non-metal, this is just nitrogen minus 3. So you need plus 1, plus 1, plus 1, and minus 3 to equal 0. So you have 3 H's and 1 N, and you have to put the AQ to tell me it is aqueous, which means all acids are dissolved in water. Actually, there's a little bit of water in all the acids, believe it or not. Okay, ionics again here, ammonium sulfide, because ammonium is a polyatomic ion. Okay, so ammonium is NH4 plus. Okay, since this is ide sulfide, that is just a regular ion, which is S2 minus. So we have NH4 plus, NH4 plus, and S minus 2, that equals 0. So my formula here will be NH4 2S. Okay, phosphorus pentachloride here. So phosphorus is a nonmetal, so we are in the covalent area here again. This is inorganic, so we're going to use prefixes. Okay, so phosphorus is P, pentachloride, chloride is Cl, and penta means 5, so it's PCl5. Strontium hydroxide. Strontium is a metal. We are on the ionic side again here, so we got to do ionics. It's very important you figure out which rules you're using here. Strontium is in group 2 on your periodic table, so it is Sr2+. Hydroxide, one of my favorite polyatomic ions, OH-. So we need a +2 and a -1, so we need another -1 to equal those out, so there's 1 strontium and 2 OHs here, so this is one of the important ones that you have to put parentheses around the OH and the 2 out there like that. Okay, sulfurous acid here. Okay, this must be an acid. How do I know that? Because it says acid. All acids start with H+. Okay, so this is an us acid here. Us acids came from ite, so we need to know what sulfite is. Sulfite is SO3 2-. So we need a +1 and a +1 and a -2. So this is HHSO3. So this would be H2SO3 AQ, because it is an acid. Because all acids have a little bit of water in it. Okay. Nickel 2 cyanide tetrahydrate. Oh boy, good fun here. This is ionic. Okay. This says nickel 2, just like it said tin 4 up here. Tin was +4 of this charge. This is nickel 2, so nickel is +2. It gives me the Roman numeral charge. Roman, get that Roman numeral for the transition metals that have charge. Okay, great song. Cyanide, Cn, minus, and then we'll handle the tetrahydrate later. So we have +2, -1, -1. So this is Ni, Cn, Cn. So this is Ni, Cn2. Okay, now this says tetrahydrate, so these are the ones with the dots. So you need to put a dot here. Okay, and then tetra means 4. Waters. Okay, it's referring back to the hydrate rules back here. Okay, and that's how you would do that one. Okay, aluminum dichromate. Hey, guess what? Aluminum is a metal, so this is ionic. So aluminum is Al. It's in group 3, so it is +3. Chromate, dichromate. Ooh, dichromate. They almost caught me there. Almost. Not quite. Cr2O7, 2-. Okay, so you have +3 and -2. So I need another -2, and then I need another +3, and then I need another -2. So that means I'm going to have 2 aluminums and 3 dichromates for this formula. So it is Al2CrO2O7 3. Cesium bicarbonate. Cesium bicarbonate is ionic. Cesium is a metal. It's in group 1. Cs +1. Bicarbonate, another great polyatomic ion. Hollister Company, HCO3 minus plus 1 and minus 1 equals 0. So this is CsHCO3. Not a challenge for us, because you guys are the prodigies, the understudies of the legend. You guys are champions. The legend is out.